let's take a look at what growth and decay look like in graph form, so visually looking at a graph. So growth, if you start on the left side of your graph, you will be increasing exponentially. So your graph will look like this. So if you were to imagine, again, like standing on the left side of your graph, it will be an incline. You'll be going up. Whereas decay, your graph will always not constantly be decreasing, because if it was constantly decreasing, it'd be linear, right? But you will be decreasing, going down exponentially. So that means that if you were looking or standing on the left-hand side of your graph, on the left-hand side of your graph, you would be going downhill. Whereas for growth, if you were standing on the left-hand side of your graph and walking, you would be going uphill to the right. So how can we look at a graph and determine the equation? Well, we want to look at first where the y-intercept is, right? So if we can look at our graph and we see that our y-intercept here, where our graph crosses our y-axis, remember this is your y-axis, and your horizontal axis is your x-axis. If we know that this is the point 0, 2, let's say, and we can identify another point at, let's say, 1, here at the point 1, 4. If we can identify those 2 points, then we can, there's a couple of ways. Well, one way in particular that I would recommend, I would create a table of, an XY table with those 2 points. So remember that these points are in ordered pair form X, Y. So I'd transfer this first point to my table and the second point to my table. So the point 0, 2 and the point 1, 4. So we know that where our x is 0 is our starting point. So we know that this is going to be our A, right? That's going to be our initial value, our starting point. And then in order to find B, our growth rate, first we know that it's growth, right? So we're going to figure out, what do I need to multiply 2 by to get to 4? Well, we can multiply by 2. So our growth rate is going to be 2. That's going to be our B. You can also go in reverse direction, do 4 divided by 2 will give you 2. So that way you know what you're multiplying by. So you can use inverse operations. So the equation for this graph would be f of x is equal to a, which is 2, and b, which is 2. So it would be 2 times 2 to the power of x. That would be the equation for this exponential growth graph. For this exponential decay graph, so again, we want to be able to identify 2 points on our graph. So let's say that we know one of the points is, let's say, 10 on our y-axis, right? So 0, 10. And then we can identify another point here at 1, 5. That wasn't perfectly lined up, right? Let's put the 1 over here. So let's say we have those 2 points. Create your XY table. Transfer those points to your table, the point 0, 10 and the point 1, 5. Again, this will be our starting value. 10 will be our starting value. And in order to figure out what we're multiplying by to get from 10 to 5, you can either know that that's multiplying by half, or you can go in the reverse direction, right? And say, well, 5 divided by 10 gives me what? So from here, you really want to keep these as a fraction, because decimals can get really weird looking. So keep these as a fraction as much as you can. So these have a common factor. 5 and 10 have a greatest common factor of 5, so I can divide both my numerator and denominator by 5. 5 divided by 5 is 1. 10 divided by 5 is 2. And that's our most simplified form. So 10 times 1/2 will give you 5, right? So really, this way, times 1/2 will give you 5. So that's our growth factor. And we know that 10 is our initial or a starting value. So the equation for this graph will be f of x is equal to a, our starting value 10, times our growth factor, which we said was 1/2 to the power of x. And if you were writing this down, of course, you'd always want to put your final answer in a box. And I'll do the same thing for the other one I had over here. Right, just good practice to put your final answers in boxes so that way your teacher knows where to look with all of this math going on.